So today I'm going to talk about the daily routine of the cell. There's been a lot of talk about this in the last 5 years, starting to open up. People like Stephen Meyer can actually talk about something else going on in the cell. I think he significantly even underestimates how complicated the cell is. And I want you to notice something. The people that know the most about the cell and biology usually understand the least. It's like the more you know, the less you understand. And you'll see that in a second. So Stephen Meyer and others, they've kind of showed mathematically to whoever will listen that using random iterations to modify DNA that codes for a protein is usually going to make things worse. And I like this idea of compounded improbability. The more steps equals more problems. Whereas Darwinists think the opposite. They think that they just say all the steps, then that's proof somehow. It's really bizarre. It's like a left hemisphere, right hemisphere thing. So they use terms like irreducible complexity, how can the flagellum or the rotor mechanism, motor mechanism for a paramecium, how could that evolve in a stepwise manner? And whereas I'm how could it even assemble in the first place? Because I have a physics background, and ever since college, I've been well, there's only really one rule that's operating in the cell. Opposite charges attract and like charges repel. And this rule is supposed to be rigid. It's the electric law for charges. And if you apply that rule to the cell, you're going to end up with a navigation problem and an instruction problem for assembling, not simply folding proteins, but taking folded proteins and combining them into larger structures called quaternary structures, like the rotor motor mechanism for the paramecium. That's whatever 40, 100 proteins stuck together. How does everything know where to go? That's the instruction problem. And that's the navigation problem. And then there's the instruction problem of how you're making this functional protein. I'll give you a thought experiment that makes this a lot easier to understand. Suppose you have a Lego Millennium Falcon. You have all the pieces, but imagine they're made of metal and they're magnetized, so that all the top ends repel the other top ends like a magnet, and then they come together. And you put it in a fishbowl and you mix up all the parts. Remember, this has no instructions for navigating or for what should go together to make functional components. And so you would never expect it to self-assemble into a Lego Millennium Falcon, right? Well, that's the complexity of maybe one protein being transcribed. So imagine thousands of proteins every minute in every cell of your every organ of every body of every organism, and it all works seamlessly. What's the compounded improbability of that, given that you're only using one rigid rule? Imagine making an algorithm with that one rigid rule, and you just set up the cell. What would happen? Everything would just crash into each other. Nothing would self-assemble into these larger structures. And also, you got to understand that natural selection can't operate on the time scale of the cell. So it's not like things can just bump into each other and form accidents and form the wrong molecules, and only the good molecules survive. It's not like that. And it's bizarre as I get older. It's less bizarre as I get older, because I realize people aren't really people. There's a left hemisphere, right hemisphere divide, in academia, it's all left hemisphere emphasized. So they don't see the problems. They just memorize. The right hemisphere is what detects problems with the theory or the plan. And the left hemisphere is busy denying that there is a problem. So you could see how that could go off the rails. And how people that know the most understand the least. Yeah, that's all I want to talk about for now.